Hello again, this is Bobby from InstallFree, and in this video I'm going to provide you with a detailed introduction to InstallFree Virtual Applications. Generally speaking, InstallFree Virtual Applications, or as we call them, IFV Applications, are cross-platform virtual applications that run on the local machine. They are comprised of separately packaged system components, application resources, add-ons, and updates. These pieces stream separately to the endpoint, dynamically bind together at runtime, and seamlessly integrate into the end user's environment. IFV applications were designed primarily to provide IT managers with the means to modularly deploy and maintain applications on demand, provide end users with the same exact experience they would get from physically installed applications, eliminate conflicts and security risks, allow for complete transparency to the host OS, and allow for granular policy management. Now let's start right away with a chart. This chart describes how an IFV application looks behind the scenes. As you can see in this chart, the first layer that comprises the IFV application is the shell shadow. The shell shadow holds all information regarding the shell integration aspects of the IFV application. This ensures that the application is presented to the OS and end user as if it was physically installed. The shell shadow includes file associations and icons, start menu and desktop shortcuts, right-click context menu items, insertions into third-party applications such as send to menus, and even the uninstall information of an application, which is displayed in the Windows Add Remove program list. This is very important because when you're using a software auditing tool, it will track these applications as if they were physically installed. The two things that are important to note about the shell shadow are, first, that it's automatically generated for any IFV application that is loaded into the InstallFree Management Console, or IFMC. It does not require any manual configurations such as creating start menu icons, file associations, etc. However you encapsulate the application, the Management Console will replicate that exact same configuration and icon display, and it posts these into the shell shadow. The second thing to note is that the shell shadow is usually the first component that is downloaded to the endpoint, ensuring that the end user can start the application in the same way he or she would normally start a physically installed application. For example, the end user can double-click on an associated file or document, and the IFV engine will run and execute the IFV application. And this brings us to the IFV engine, which together with the language base forms the runtime environment for all InstallFree virtual applications. The InstallFree Virtual engine can be thought of as a just enough operating system, which means it's like a regular OS that was stripped down to a bare minimum and left only with the most essential resources. It's important to understand the IFV engine is not a virtual machine, but more of the essence of what an operating system provides applications so that they can run normally. There are a few things you should note about the IFV engine. First of all, it's compact, has a small footprint, and can run identically on almost any Windows-based operating system. It runs completely in user mode, meaning that it does not require any installed kernel mode components such as device drivers. It includes within it all the resources an application needs in order to run while decoupled from the OS. And these components include a virtual file system, a virtual registry, virtual named objects and service manager, a virtual security and permissions manager, a virtual side-by-side assemblies, and more. This not only means that the IFV application runs exactly the same no matter what platform you're running it on, but it also makes sure there are no application conflicts over shared resources. And finally, once the IFV engine is launched, it covers itself with a sandbox protection layer called the Power Guest. Now let's focus a bit on this Power Guest layer and its function, since it contains within it one of the greatest benefits of IFV applications. First of all, the Power Guest layer denies all write permissions to the OS, even if the user is logged in as an administrator. This means that no matter what a user does to his IFV application, or if and how it was compromised, the danger will never leak out to the physical OS. To take it even further, the Power Guest layer allows the user to have elevated admin type privileges from within his virtual applications, even when logged into the host as a limited or guest account. This means that you can finally lock down all of the PCs in your organization without locking down your users. Now think how that can change your life in real-world examples. You get all the benefits of a secured lockdown OS, because in the case of a virus, it would infect only your virtual runtime environment, not the actual OS. And at the same time, your users will still enjoy a rich computing experience that does not hinder their productivity. They will still be able to install the Flash player they need, Google Toolbar, create their bookmarks, whatever they would normally need to do, because it'll be installed into this virtual runtime environment, not the actual OS, where they have no privileges. Now that you understand the advantages of the InstallFree engine, let's go on to discuss the second crucial element of the virtual execution environment, the language base. The language base plays two vital roles in the operation of IFV applications. First of all, as their name suggests, they include all the language resources an application requires. But more importantly, they can also contain one of InstallFree's most unique attributes, a fully virtualized and autonomous Internet Explorer, which is completely detached from the physically installed version of IE and shares no resources with it whatsoever. This means that you can run conflicting versions of IE on the same machine, which is extremely useful in cases where you have legacy applications that require IE6, which is no longer available in newer operating systems. Another great benefit of this feature is in situations where you have web applications that require an outdated plugin. For example, an older version of Java runtime that's not compatible with newer applications that the user might also need to run. Moreover, the virtual IE plays a pivotal role in cases where your virtual applications require a strong link with a web browser, such as with Microsoft Office and SharePoint. No other application virtualization technology in the market today provides these benefits. Now, let's move on to the AOD file portion of the IFV application. AOD files are really the main building blocks of the IFV application, and their acronym stands for Application on Demand. Generally speaking, Application on Demand files usually contain all the executable and system files, registry entries, and DLLs that were written during an application's installation. These are downloaded or streamed at block level to the endpoints for local processing. Now, AOD files come in four distinct flavors. You have dependency AODs, which are application on demand files that include all the system data and executable files of dependencies without which an application would be able to run. For instance, .NET Framework or .NET Applications. You have application AODs, which include all the system data and execution files of the base application. You have update AODs, which are files containing the delta between two application AOD files of different versions. For instance, Firefox 3 and Firefox 3.5. And lastly, you have the expansions AODs, which are AOD files that include all the system data and executable files of an add-on or plugin, but can also include registry key changes or system tweaks. There are a few important things to know about AOD files. First of all, AODs do not include any form of hard-coded configurations embedded in the packages, meaning that there is no need to configure during encapsulation process things like the users that have rights to access the application, shell integration aspects, and linkage between separately packaged AODs. AODs do not require hard-coded configurations of an application's integration with other applications in the OS. Application distribution is implemented completely through our management console, avoiding any policy creation to publish applications. The same AOD file can run on almost any Windows-based machine regardless of its OS version, configuration, and installed applications, eliminating the need to create different packages designated for different OS versions and endpoint configurations. AOD files are stateless, meaning they cannot be changed in any way by the end user actions. So all the users in the company are actually running multiple instances of a single AOD and have a personal user data file attached to it to capture the changes imposed by the end user. Finally, AOD files have an inherent ability to dynamically bind at runtime with each other without specifically configuring them to do so, meaning that it is enough to place all the different application dependency, expansion, and update AODs in the same IFV engine runtime environment in order for them to seamlessly converge and manifest themselves as a single application. This extremely unique feature enables you to modularly build your IFV application inventory which means, for instance, you can deploy a single application AOD of Microsoft Office to the entire organization, and separately deploy expansion AODs containing different add-ons for different users, depending on their role in the company. Moreover, it allows you to add, update, remove, and replace particular components of IFV applications without repackaging the entire application from scratch, greatly minimizing the number of packages you need to maintain. Now, the dynamic binding I've just mentioned also plays a role in the convergence of user data file with the rest of the application to create the user's own customized application without changing the original AOD image. This user data file, known as the AOK file or Application Output Keeper, is an external file that collects all customizations and changes made by a user that would normally be written into the application system files or even written into the underlying OS. This allows the simulation of administrator privileges inside the IFV applications. It's how we achieve a user-friendly lockdown. Within their IFV applications, users can now install their own add-ons, change the application's appearance, etc. And depending on the configuration, user data can also store temporary files or even data files saved into this virtual drive, which appears as the drive letter V. Apart from its obvious role as a keeper of customizations and its use in roaming user scenarios, the user data file can also play a role in disaster recovery. For instance, if a user compromised his application or damaged it, all you need to do is either restore his old user data or just delete it, and the application will be reset to its original state. And if configured, the user can actually do it by himself. And when I configured my Outlook to be exactly as I wanted, it is all saved into my user data. Now, if I wish to move machines, the user data will simply bind with any Office 2007 AOD holding Outlook and be completely operational instantly. Okay, this includes all operational parts of the IFV application, leaving us with the final policy configuration layer, which allows policies to be managed without hard-coding them into AOD packages themselves. This is a major differentiator, as we can control exactly how much or how little an application is allowed to interact with the host OS or other applications. The policies you're able to set include everything from the way IFV applications interact with its host, availability type, and access duration. You can even control the application's service name in the task manager, and also the username which the application uses when it connects to the outside world. Again, the great thing about this is that it dramatically improves your flexibility in deploying and managing applications, while at the same time allowing you to keep packaging to a bare minimum. A different policy can be implemented per user, per machine, per OU, or the entire domain, or you could even set these policies per application. And finally, before we finish, I want to go into some of the inherent abilities IFV applications have to interconnect with both their virtual and non-virtual surroundings. And I'm not going to provide a complete view of the interconnectivity features, as they are broadly discussed in the technology and system structure overview, which also explains the role played by the Bridge Virtual client in providing some of these abilities. But let me summarize by saying that IFV applications can freely communicate with their environment, whether virtual or not, since, although sandboxed in an enclosed environment, they are still transparent to the OS and to other applications running on the OS. This assures a natural user experience that guarantees your users will never notice they are working on a sandboxed virtual application. This concludes the IFV Applications technical overview. Thank you very much.